In the vast expanse of our night sky, we often marvel at the occasional streak of light, commonly known as a shooting star. These fleeting moments of celestial beauty are more than just visual spectacles. They represent a continuous shower of cosmic material onto our planet. While most people associate meteorites with rare, large impacts, the truth is that Earth is constantly bombarded by tiny particles from space, known as micrometeorites. This phenomenon, often overlooked due to its microscopic scale, plays a significant role in our planet's ongoing interaction with the cosmos. Contrary to popular belief, meteorites are not as rare as one might think. In fact, they're ubiquitous, just on a scale that's typically invisible to the naked eye. Every day, Earth encounters dust particles originating from asteroids and comets. As these minuscule fragments of space debris enter our atmosphere, they create the mesmerizing effect we know as shooting stars. However, the journey of these particles doesn't end with their fiery descent through the sky. When these dust particles cross into Earth's atmosphere, they don't simply settle on surfaces like household dust. Instead, they undergo a transformative process. The intense heat generated by their high-speed entry into the atmosphere causes them to burn up, creating the luminous streaks we observe. But contrary to what many might assume, this process doesn't completely obliterate the particles. A significant portion of this cosmic dust survives its fiery journey through the atmosphere, albeit in an altered form. These survivors are what scientists refer to as micrometeorites. More than a ton of these tiny space travelers land on Earth's surface every day, accumulating to an astonishing annual total. Recent scientific estimates suggest that our planet receives approximately 5,200 tons of unmelted micrometeorites each year. To put this quantity into perspective, consider that an adult hippopotamus weighs about 5 tons. This means that the annual accumulation of micrometeorites on Earth is equivalent to the weight of more than 900 hippos. It's a staggering amount of extraterrestrial material, continuously and silently added to our planet's mass. The size of these micrometeorites is truly minuscule, typically ranging from 30 to 200 micrometers. To grasp just how small this is, consider that a single grain of table salt is larger than the biggest micrometeorites. This microscopic size explains why we don't notice their constant rain upon the Earth's surface. They're simply too small to be perceived without specialized equipment. Given their tiny size, one might wonder how scientists manage to quantify the influx of these cosmic particles. The process of studying and measuring micrometeorites presents unique challenges due to their microscopic nature and the vast areas over which they fall. However, researchers have developed ingenious methods to overcome these obstacles. One of the most effective locations for studying micrometeorites is Antarctica. The vast, white expanse of Antarctic snow and ice provides an ideal backdrop for identifying these tiny specks of space dust. In this pristine environment, the dark particles stand out against the white snow, making them easier to spot and collect. Scientists conduct meticulous searches in these polar regions, carefully examining the snow and ice for these minute extraterrestrial visitors. The Antarctic method involves collecting snow samples and melting them under controlled conditions. The resulting water is then filtered, and the residue is examined under microscopes. This process allows researchers to identify and count the number of micrometeorites in a given area of snow. By analyzing the concentration of particles in these samples, scientists can estimate the rate at which micrometeorites are falling in that region. However, the data from Antarctica alone isn't sufficient to determine the global influx of micrometeorites. To extrapolate these findings to the rest of the planet, researchers must consider various factors. These include differences in atmospheric conditions, variations in the Earth's magnetic field, and the uneven distribution of landmasses and oceans across the globe. By combining the data from Antarctic studies with mathematical models that account for these global variations, scientists have been able to estimate the total amount of micrometeorites falling on Earth each year. This extrapolation process is complex and involves ongoing refinement as new data becomes available and measurement techniques improve. The study of micrometeorites extends beyond mere quantification. These tiny particles offer valuable insights into the composition of asteroids and comets, providing clues about the early solar system and the materials that formed our planet. By analyzing the chemical makeup of these cosmic visitors, scientists can learn about the conditions and processes that existed billions of years ago, when our solar system was forming. Moreover, the continuous influx of micrometeorites has implications for our understanding of Earth's geology and atmosphere. Over billions of years, this steady rain of extraterrestrial material has contributed to the planet's mass and may have played a role in delivering water and organic compounds essential for life. Some researchers even speculate that micrometeorites might have been crucial in seeding Earth with the basic building blocks of life during its early history. The presence of micrometeorites in Earth's atmosphere also affects various atmospheric processes. These particles can serve as nuclei for the formation of clouds and may influence weather patterns on a microscopic scale. Additionally, they play a role in the upper atmosphere's chemistry, potentially affecting phenomena like the ozone layer and the ionosphere. As technology advances, our ability to detect and study micrometeorites continues to improve. New collection methods, such as using high-altitude aircraft or specially designed rooftop collectors in urban areas, are expanding our understanding of these cosmic particles. These techniques allow scientists to gather samples from different altitudes and locations, providing a more comprehensive picture of micrometeorite distribution and composition. The study of micrometeorites also intersects with other fields of research. For instance, examining the accumulation of these particles in deep-sea sediments and polar ice cores helps scientists understand past variations in the cosmic dust flux. This information can be correlated with other geological and climatic records, offering insights into long-term changes in our solar system's environment. In conclusion, the constant shower of micrometeorites on Earth is a remarkable reminder of our planet's connection to the cosmos. Far from being rare events, meteorite falls occur continuously on a microscopic scale, invisibly adding to Earth's mass and composition. This ongoing process, difficult to observe but significant in scale, highlights the dynamic nature of our planet's interaction with the solar system. The study of micrometeorites not only enhances our understanding of Earth's place in the universe, but also provides valuable data for various scientific disciplines. From astrobiology to atmospheric science, the insights gained from these tiny cosmic travelers continue to expand our knowledge and spark new questions about our world and its place in the cosmos. As we look up at the night sky and marvel at the occasional shooting star, we can now appreciate that it represents just a visible fragment of a much larger, ongoing cosmic phenomenon that shapes our planet in subtle but profound ways.